This is video number 21 in which we are going to discuss about the electric field due to a point charge. So look at this figure. Suppose in a coordinate system at origin some capital Q charge is kept, and at distance r, suppose there is a point P where 1 coulomb charge is kept, or suppose Q equals to 1 coulomb, but at the end I will be writing the Q equals to 1 coulomb because here we are going to calculate the electric field due to a point charge. Okay, so at the end of the discussion you will be knowing that there is no use of this charge, the whole use of this capital Q, because our focus should be on this only. So hope you understand. A capital Q charge, there is a point P at distance r, and at point P we want to calculate the electric field, or you can say the effect of this charge at this given point, that is only the electric fields. How can be done? So suppose, because there is, as we have seen according to Coulomb's law, because whenever there are 2 point charges and they are kept at some distance, definitely very first they will experience a force. So force according to Coulomb's law between these two charges at distance r can be given by this K capital Q small q upon r, because one charge is capital Q, another Q1. Instead of Q1 we are taking capital Q, instead of Q2 we are taking small q. So it is simple to understand. R is the distance. If I take the modulus of this vector, I will get the R, because R is nothing. We have seen before also, the modulus of any vector is equal to the scalar. So this is R. So it's a Coulomb's scalar form we have seen. Now if I remove the Q charge from here, because I have to calculate the electric field, and keeping the definition in mind, we have to separate the small q, or the charge, this one charge which is experiencing some force because of this heavy charge. You can understand, it's a common sense that small q is integrating some poor charge or small charge, where capital Q is heavy charge, means suppose it is 5000 coulomb or like this, and it is just like 1 coulomb or 2 coulomb like this. So that's why it's a understood thing that when we are writing capital Q small q, means one is very powerful, another one is very poor, and we have to take it very poor. Because of that only there is the meaning of talking about the effect of this charge. So back to the here, after applying the Coulomb's law, if I separate the small q on F upon Q, it will left behind K capital Q upon R square, and F upon Q, if you remember the previous video, it is nothing, it's a electric field. So I am going to replace F upon Q by capital E, which is electric field, is equals to the K Q upon R square. Now hope you understand, this is the electric field due to a charge capital Q at some distance r, is given by E equals to KQ upon R square. This is the important formula which will be helping us to solve the lots of numericals here. Now this is the scalar form. If you want to write it in the vector form, because I have already shown the vector, so it also can be written in vector form. It is a vector quantity as well, but for numericals we will follow this only, or sometimes we will also use this, because numericals will be based on both of scalar form as well as on vector. So E equals to, you can see, KQ upon R square, where R kept. So it's a electric field at some distance r, or position vector is given by KQ upon R kept. So this is the something which we have calculated from here. Our title was here, the electric field due to a point charge. Electric field due to our point charge was capital Q. So its conclusion is that due to point charge capital Q at some distance r, the electric field is given by E equals to KQ upon R square. Thank you very much.